Hey guys, so we're working on part 9 of the Regents Review short answer questions in this video. So question number 1, base your answers to questions 1 through 3 on the data table below, on the graph in your answer booklet, and on your knowledge of earth science. The data table shows the projected percentages of radioactive isotope X remaining and its disintegration product Z forming over 6.5 billion years. The graph shows the disintegration of radioactive isotope X. So, number 1, on the grid in your answer booklet, construct a line graph by plotting the percentages of disintegration product Z forming over 6.5 billion years. Connect all 6 plots with a line. The percentages of radioactive isotope X has already been plotted. So what it's saying is you have radioactive isotope X, and since it's radioactive, it's disintegrating. It's breaking down and turning into its disintegration product Z, and it has a half-life, so it takes a certain amount of time to go from 100 to 50% to 25%. So halving every time, it takes a certain amount of time every time. So this graph that's already given to you in your answer booklet, you already have a graph of the radioactive isotope X as it's disintegrating over time. What this is asking you is to graph the disintegration product Z that is forming as the radioactive isotope X is disintegrating. So we're just graphing this column right here over time. And your answer should look something like this. As radioactive isotope X is disintegrating exponentially, your disintegration product Z should go up or exponentially as well, grow exponentially as well, because isotope X is creating disintegration product Z. Next, number 2, identify radioactive isotope X. The way to do this is for any radioactive isotope, you can look at its half-life to figure out what isotope you're looking at. So for radioactive isotope X, when it goes from 100% to 50%, that's one half-life. And it's for one half-life, it takes around 1.3 billion years. If you go to your and you can also see it from your chart over here from 100 to 50, it takes 1.3 billion years. If you go to your reference table page 1, you'll see that potassium 40, the radioactive isotope, uh, takes 1.3 billion years for one half-life. And its disintegration products are also shown, argon 40 and calcium 40. So your answer should be potassium 40, K40, or something like this, but you cannot say potassium or K alone because those are not radioactive. Number 3, calculate the amount in grams of an original 300-gram sample of radioactive isotope X remaining after 3.9 billion years. We can see from the chart after 3.9 billion years, the amount of radioactive isotope X we have is only 12.5% left. So we started with 100%. After 3.9 billion years, we're left with 12.5. If I had started with a 300-gram sample when it was a 100%, it's asking how much I have left if I only have 12.5% left after 3.9 billion years. So you're going to do 300 grams because that's what you started with times the percentage of however much you have left. So since I have 12.5% left, I'm going to do multiplied by 12.5 divided by 100. So any percentage is always written by the number divided by 100. 12.5 would be represented as 12.5 divided by 100. So 300 grams times 12.5 divided by 100 will be 37.5 grams. So we started off with 300 grams when it was 100%. At 12.5%, we're left with 37.5 grams. And that's it.